All right, thank you everyone. My apologies for the technical delays. Just a brief note, if you are watching the record, or rather if you're online now or you're going to watch the recording later, we have had to disable the output to our fancy kit at the back. So what you're seeing on the screen is directly from Ariella's laptop into that projector, which means what you'll see online is what the camera can show you over the screen. Our apologies, the quality there will be a little bit iffy. I'm hoping, Ariella, obviously these are slides, will be available. You could make them available after the talk. Okay, perfect. I'm not going to take any more time by introducing Ariella Rink, although I will note it should be Dr. Rink, who has a doctorate in stuffs. But she will tell us about herself, and in the interest of no further delays, Ariella, please.
Okay. So I've sort of gone from bugs of one kind to bugs of another because I got my degree in ecology, but that's also where I became familiar with programming, specifically in R, and where I fell in love with data and decided to pursue a career pursuing the digital bugs rather than the organic ones. After my degree, I did a year of postdoc, and then I was an app dev at a fintech startup called LifeCheck, and then from there, here I am with the city at a PyCon conference, which is a language that I only started learning at the city, so imposter syndrome. As a result, this talk is not going to be code heavy. It's rather going to be about the concepts and the difficulties we faced on this project. So I'll just start by introducing you to the data science branch, what we do in the city, the sorts of common data challenges we face, and then how those challenges led to us pursuing a framework for measuring and monitoring data quality with an introduction to what data quality actually is, what we implemented that was part of my onboarding process at the city, and then passing the baton on to the next poor newbie who is developing V2 of that. So I think this was Yolanda mentioned a bit earlier. She gave a bit of introduction for those of you who were in her talk. Apologies for any repetition. But we're the data science branch. We act as a sort of central advanced analytics-driven unit in the city. And so we provide services and advanced analytics-driven services to any departments or any directorates, any other units within the city that require advanced analytics work. So there are other analytics units distributed throughout the city, and then we are sort of the high-tech one, apparently. But we issue the city systems. So when you think of government, you think of bureaucracy, you think of long procurement times, expensive, inefficient packages. We try to go open source as much as possible in our tech stack, including Python. Apologies for the logo being really tiny and right at the end of that list. That wasn't intentional. And we use Discord for our IMs, which always gives me a chuckle. And we're a mix of expertise across all sorts of different disciplines, but we try to be as cross-functional as possible. So we're data engineers, data scientists, me and Catherine being the data analysts, and we're supported by product and project managers. So working in such a big organization, I think yesterday, for Gordon's lightning talk, it was mentioned that there's over like 20,000 employees. There's tons of data, there's tons of legacy systems, lots of manual processes. The city's core data tech stack is oriented towards transactional data primarily, not analytical data sets. The systems themselves are complex, and then there's lots of them that interact in often broken ways. Data ownership is often also decentralized, even though that's not the intention within the city. And so for all of these reasons and more, which I'm sure people in startups and also much smaller private organizations can also relate to, you often spend, everyone has made peace with the fact that you're going to have to clean your data before you can do anything useful with it, because that's how the real world works. But, we really want our clients within the city to trust what we're doing. We are a bit of an unknown entity within the city. And we want, at the end of the day, the results of our analyses to be meaningful, to be useful, to reflect reality, and to be able to optimize service delivery in the city. And for all of that, we need data that's actually fit for purpose. And sometimes, to a greater or lesser extent, the data that we receive from the city systems are unfit for purpose. And so that brought us to wanting to measure and monitor in what way is data unfit for purpose? What's the purpose we want to use it for? What does the data look like? And is it fit for this purpose? Is it unfit for that purpose? Are we going to have to give a proviso on our analyses that we need to run in order to provide a product that the client has, the client being another department in the city, that they've requested? Or do we actually need to advise them to put a halt on publishing that product at all, and rather advise them actually, we feel that there's some upstream processes that need to be fixed before we can, or that need to be addressed before we can even proceed with the analyses, with the original intention of this stakeholder interaction. So we've decided to implement some sort of data quality tracking. And in the world of data quality analysis, monitoring, and measuring, it's often broken down into dimensions. And the actual dimensions themselves differ according to which blog post you're reading or which white paper. But essentially, dimensions are like unitary components of this much broader amorphous topic of data quality. Like, what is data quality? What does it mean? And so for any specific use case, you can assess which dimensions of data quality are actually important to you, given your use case and given the data you have access to, because data that's unfit or has poor data quality along one dimension might actually have excellent data quality along another dimension. And perhaps, for example, the data is terribly out of date, but that doesn't matter for your use case. You're not, you don't care about time series analysis. You're not looking at trends over time, but it's got perfect completeness, and that's actually what matters to what you're doing. So we, before I talk about what we've done, here's some very basic examples, but basically, even when you're dealing with millions of rows of data, the principles remain the same of what it means to look at data quality along these dimensions. So the first, I'm just going through a couple of them here. The first dimension is completeness. And just for an example of how it manifests, the impacts it can have, and how it can signal upstream issues with upstream processes. I think this is a really simple example, but it shows all of those things. So, for example, if you're a small retailer and you want some simple summary stats on your orders over the last week, and you want to know what was my least valuable order, what was my most valuable order, and what was like my average order value over the last week. You've got other staff members, and for example, say you have manually written out invoices or printed invoices, but they're manually entered into some sort of spreadsheet software like Excel or whatever. And you ask your money person or whoever, the transcriber, the clerk, can you get me these numbers? And they do. And you've got there's no errors. You've got a value for you've got an answer for each of the questions you asked. But you actually remember, there was an order that did come in that was worth much less than 300 Rand. And you look at the actual source data and you realize that for most of your orders over the last week, there aren't any order values. So that somewhere something went wrong upstream. And if luckily you kept your original invoices, you fill in the missing data, you get the true metrics that you're after. So now this data is meaningful, it's useful, it reflects reality, and you can action on top of that. And also, interestingly, this just serves to show that data quality. It's all very well to say, data quality, data is like perfectly up to date, or completeness is only at 50%. But that doesn't really mean anything. The point of data quality, of measuring and monitoring data quality, really is to assess where So yeah, it's just a means to an end. So it's to assess where your data is useful, what you can do with it. Is what a client's asking us to do with the data they've provided to us impossible? Or can we make some recommendations for upstream improvements in the future? Here's an example of the validity dimension of data quality. So if you're, oh, wait. Oh no, I've lost my memes. So validity is a dimension that refers to how well your values in a certain field or across whatever scope you're interested in conform to an expected format. So for this example, in terms of date time, you might be expecting dates to be rendered as year, month, dash, day. But for example, maybe you haven't enforced that in your schema. Now you have dates that are all over the place, and it's impossible to do time series analysis with this data because what does that mean? You can't even ground truth it or check it against anything after the fact if you don't have your like original source data, or if it was entered just like this. But this data still, if you don't care about any time series analysis, its completeness is 100%. If you just want to look at like mean order value, that's fine. So it's about understanding the limitations of the data as well. To not just say this data is useless, to say, okay, it has its limitations, we can still do X, Y, Z with it. And another example of validity that shows sort of a more insidious silent fail is, for example, with numeric formatting. So here, there's the data entry again has been unsupervised. Perhaps training's been insufficient. People have entered numbers in different formats that the software doesn't pick up. And if you were just looking at the totals, you wouldn't pick up an error because it's given you a total in both cases. In the case where the formatting's incorrect and where it's correct, it's only by inspecting the data, the underlying data, that you realize this value is actually wrong because it hasn't detected these two values as amounts. So it can be quite tricky to pick up. And then a last one is uniqueness. Sorry, there's supposed to be memes here. Yeah. So for example, in the city, say these are people and you have an account that you're trying to validate, you have a rates account and it's for GH65. Now, who is GH65? Whoever designed this, what's supposed to be a unique key, it's not unique. There's no way to resolve just based on that key who that data is referring to. Uniqueness can also be a measure of informational density stored in data. Sometimes it always depends on context. So sometimes it's perfectly valid for values to be repeated. Other times you want maximal information density, as for the example of a unique key. There's a meme. Okay. So as I think this is redundant for me to go through again, but understanding data quality is important because really it's a canary in the coal mine. It points to upstream processes. It signals just about anything else in the business or organization that affects data where something could be going wrong. And it also has real-world consequences. It can, especially if, for example, we're working in the city, we're working with real people's information, and it has real impacts on how service delivery is carried out and how functions within the city are carried out. Just brings that home. And there's a tendency, to want to fix this after the fact. So in the first example, the completeness example, the business owner goes back and luckily he can retrospectively, fix that data quality issue. But when you're working with millions of rows of live data, it's really a futile task to do that, and is hugely expensive in terms of personnel time and cost. And you might as well not, because you're not addressing the underlying concern. You're putting a Band-Aid on the problem. So it's much better to rather assess where there are issues with data quality, make recommendations for how those can be addressed and then monitored to track progress and to track the response to those interventions if hopefully they're implemented. So our approach was to start really simple. We just wanted to do an MVP. We looked at 3 dimensions of data quality. We didn't want to reinvent the wheel, so there are a number of off-the-shelf data quality packages available. This, with the advent of big data, this has become more and more of an issue that companies have had to face. In the 2 examples that I really delved into, they're both companies that started as small startups, and the scaling of that from a small startup to like a multinational corporation, they realized that their data processes hadn't scaled and that their data was getting leakier and leakier and less relevant and more useless. And they really put a big effort into addressing that, and it they were successful. So we looked at the uniqueness, completeness, and timeliness dimensions of data quality. So completeness, how many missing values are there? Uniqueness, we looked at how many, across rows and columns, how many unique rows did we have? We expected to have, 100% unique rows. Some columns are allowed to have, say, lower uniqueness depending on the scope of the field schema. And timeliness, how fresh is our data? And timeliness depends not only on the data that we're fetching from the city systems, but also on our internal pipelines. So that allows us to detect, was there a silent fail somewhere that we didn't pick up? And actually this data we're expecting it to be 14 hours old, but it actually hasn't updated since 3 days ago or whatever. The main packages we looked at that are both, they have several options. They also run their own systems, but that are executable in Python were Great Expectations and to a lesser extent Soda. And then the companies that really had good, well-documented case user experience stories of their journeys towards measuring and getting on top of data quality were Airbnb and Lyft, which is like a US-based rideshare company. So, the rant. So, it turns out that even when you try to do things simply, it gets complicated. So, the Great Expectations and Soda, they try to be really applicable across the board. They try to accommodate lots of different use cases, lots of different data formats, interest in different metrics and different ways of outputting their results, etc. But they still make assumptions about the data structure. And in our case, Great Expectations actually had a flavor that was specifically tailored to, we thought, to what our situation was, which was Parquet files in Trino. It was the Trino flavor. And it took hours to run, for example, like a completeness test that you could just, write a simple function totally, you write a function yourself for, because as I showed in these examples, like understanding completeness isn't complicated. It doesn't matter if there's 10 rows or 10 million. It's a very simple operation actually, and this was taking hours to run. It was breaking our pipeline, and Gordon, our lead data engineer, realized that it wasn't considering, it knew, okay, this is Trino, it knew how to connect to Trino. It wasn't optimized to Parquet files. And another example is, so Fahim's not here, but he took over this project for his data engineering onboarding task. Another problem is keeping up with updates. So I wrote this V1, this MVP, using a certain, I think it was 0.18, 0.19 of Great Expectations, and then it updated when he was using it, and suddenly a whole lot of things broke. So a bit of a black box situation. We also ran into a lot of confusing documentation. These are young packages that are still doing a lot of major development work, and it was a steep onboarding ramp to actually become familiar with them. And this was getting more and more frustrating when we were like, just write this ourselves, and then it won't be a black box, and we'll be in control of the whole process, and we'll have insight into how everything works, and we'll really be able to tailor it to our needs. And what we were also realizing was that even though we were just looking at these 3 dimensions of data quality that we thought were pretty generic and pretty applicable to any data set, we realized how important domain specificity was becoming. So completeness is, you'd always think, okay, you want your data to be more complete, but actually some fields aren't mandatory, or some fields aren't needed in your analysis. So we really wanted a package where you could tweak these things and say, give it, like, really have control over the inputs and outputs. And also, a really weird oversight with a lot of the off-the-shelf packages is that they don't give you the failing values. Like, I want to see what failed. Isn't that obvious? I don't want to just know, timeliness failed, or I want to know, for timeliness, for example, if it fails, I want to know what the most recent value was, or if completeness for across the whole data set was 40%, give me the primary keys or the whole rows of the values that failed, or whichever fields I specify, but show me what failed so that I can act on that, because the point of the whole exercise isn't to just be able to say, oh, it's 40% complete, but to actually be able to remedy that going forward. So, I'm glad this one worked. So, yes, in the research I did on what companies before us have done, Airbnb and Lyft did not use off-the-shelf packages. They built their own systems from the ground up. And so we're taking their lead, we're rolling our own. We're embracing the fact that even though it's an MVP, we wanted to have flexibility. We want to prototype that flexible feature, that flexibility as a feature early on, because we know going forward it's going to be really important to be able to have full control over the fine-grained details of this package, because we're not going to only be using it internally. There's also a hope that as part of our evangelizing in the city, that we can encourage self-service analytics, and so that other analytic units or anyone else in the city who's interested in a certain data set can plug it into this framework and understand a bit more of what's going on, how trustworthy it is, and become more familiar with the practice of analytics. Because I think at the moment it's a bit of a big, scary unknown. So, yeah. That's it.
Right, thank you. Thank you, Ariella. My apologies again that you got going so late and so you felt you had to rush a bit, but you covered it perfectly, so thank you very much. Do we have any questions for Ariella? Yep.
Thank you for the great presentation. I'm curious, how do you deal with the completeness of sensitive data, let's say electricity bills?
Yeah. So, some of the more senior teams might be able to answer this with a bit more sensitivity, but we are internal to the city. So I think there are concerns around personal data in the city, but at the end of the day, we're using this to, we're not using this to gossip about so-and-so so much on their bill. We are exposed to people's personal information, but it's part of our professional mandate to not expose that to the wider public and to, use it for whatever the task at hand is. Does that answer your question? Yeah, the Poppy Act's a big concern, and it's quite strictly monitored.
They'll probably, so other people can hear, is I think our experience has been too that, we're obviously, as Ariella has said, we're very concerned and we've done a fair amount of Poppy-related training, but the good news is that to do good analytics, it's very rare that you need sensitive personal information. We tend to be interested in things on aggregate.
Yeah.
It's only in very, very particular applications where you're targeting individuals. And so as a rule, when we're building our analytic data sets, if we can get away with not including personal details, for example, an indicator that there is a phone number or there's a phone number with a valid number of digits, that's often all you need. You don't need the actual phone number, right? So you
There's
know
too much data for us to eyeball it all anyway.
yeah, exactly. So yeah, I think it's something we do worry about, but it's also something that there's the other side of this is that there's a bit of a chilling effect that we've been seeing, where the moment there's personal information in a data set, people stay away from it. And they're like, no, we can't analyze this data. There's personal information in it, and that's the wrong thing. I don't think that's what the people who wrote Poppy and the enactors envision, right? And so we've got to be. That's the other thing that we're just sort of trying to balance, right?
Sorted. Thanks, Gordon. When Ariella said for some of the senior people would answer the question, I did think she meant you. No, cool. Fair enough. So,
Thank you. Thanks for a great presentation. So I just wanted to understand, I know that data quality is a shared responsibility within an organization, right? But how do you ensure, or what are the principles or policies that you've put in place to ensure data controls, like i.e. that will be putting controls within
Yeah.
your front end systems to ensure that correct data is captured? A lot of companies don't always get that right because data departments will be sitting elsewhere and then front end development sitting elsewhere. So what is the mechanism that you use to ensure those controls are put in place when developing?
Okay, so unfortunately, basically all of that is outside our control. All we can do is influence our stakeholders and make them aware that these are issues, because ultimately the city runs on SAP, and that's under the ambit of IT, and either things are actually difficult to change or they aren't, but there's bureaucratic resistance to that. It's like a huge, slow-moving behemoth. So we try to manage as much as we can, but we don't have direct influence over that. So it's an exercise in frustration. But yeah, we're trying to at least increase people's data awareness, understanding of the whole system. Yeah.
Hi. So when you're building these data quality like alerts and stuff, like what have you found is the best way to alert about it? So you have like your pipelines that are running, and when they
Yeah.
fail, that's a software issue. But then if you have like a
Yeah.
data quality slipping, you don't want
Yeah.
someone to tell you that you need to write a postmortem because a row is missing. But what strategies have you applied?
So it's still under development, but in the meantime, for like that first MVP I did, we integrated it into the existing pipeline that processed the data set it was testing. And that pipeline ran twice a day, and we ingested that into a dashboard that ran twice a day. And I set it up to just send me scheduled emails, so I could monitor it as like a test case. In other circumstances, we might want to send like more, send alerts maybe on Discord, or to run them ad hoc. So there's like an on-demand version and there's a scheduled version of this. We can send internal alerts, like I demoed with the MVP, or we could send alerts to other stakeholders in the city, depending. So there's lots of scope for how this gets used once it's built. And I'm sure it's not going to be built. It's going to be constantly iterating as we find new use cases for it, as we get more feedback on it, and as hopefully we get more buy-in from other data practitioners in the city.
thank you. Any further questions? I'm guessing not. So, fantastic. Thank you, Ariella. We missed you around. We started 15 minutes late, and you're already on time. Fantastic.
Sorry. I introduced my own bug by messing up the the memes. Anyway.